So right now, you are currently standing at the very end of a supply chain that is, well, simultaneously one of the greatest victims of climate change and also one of its absolute worst culprits.
Yeah, it really is a paradox.
Right. I mean, every single time you sit down to eat a meal, you are actively participating in this massive, deeply interconnected system that is just like buckling under unprecedented stress.
It is a sobering reality because, for the last century or so, modern food production was built on this underlying assumption of total environmental predictability.
Like the seasons will always just do what they've always done.
Exactly. We assumed the rains would come when they always came, the temperatures would remain stable, and the soil would just indefinitely support whatever we demanded of it.
But that baseline of predictability is basically gone.
It has completely vanished.
Which is exactly why we are taking you on this deep dive today. We are looking at a really comprehensive brief titled Organic Food and Climate Change.
It's a fascinating document.
It really is. And our mission today is to move completely past the supermarket marketing hype, right? We want to look past the shiny green labels, past the premium price tags, and figure out if organic farming practices actually hold the mechanical keys to building a climate-resilient food system.
Right. And to do that, we have to look closely at the biological mechanics happening out in the actual fields.
Yeah.
And then connect those mechanics directly to the global atmosphere.
Yeah.
Because this conversation is, it's far more complex than just avoiding synthetic pesticide residue on an apple.
Right. It's not just about eating clean.
No, not at all. It requires a fundamental shift in how human beings interact with the Earth's natural cycles.
So let's start with the problem itself. Because the research paints this really fascinating, almost tragic picture of modern agriculture.
Tragic is a good word for it.
Yeah, it's caught in this devastating feedback loop. I mean, we all know that farming is vulnerable to climate change. We've all seen the news reports, right? Rising temperatures, prolonged droughts, just baking the Midwest.
Catastrophic floods wiping out entire harvests.
Exactly, and entirely shifting growing seasons.
Because, farming requires stability. And climate change is essentially the definition of instability.
Right.
But agriculture isn't just passively taking these hits. It is an active driver of the crisis. Global agricultural activities contribute a massive portion of the world's greenhouse gas emissions.
And the research points specifically to things like intensive land management, heavy machinery, and perhaps most importantly, the production application of synthetic fertilizers.
Yes, the synthetic fertilizers are a huge piece of this puzzle.
So think of modern agriculture like a highly stressed person who is trying to cope with an anxiety disorder by just chugging pots of espresso.
Oh, wow. That's actually a great way to look at it.
Right. Like they feel overwhelmed, so they drink more coffee to power through the day. But that quote-unquote solution actively spikes their heart rate, ruins their sleep, and basically makes the underlying anxiety infinitely worse.
That analogy maps perfectly onto the agricultural landscape. As the climate changes and the weather becomes more erratic, conventional farms experience intense stress.
And the yields threaten to drop.
Exactly. So the system's coping mechanism is to just pour on more synthetic nitrogen fertilizer to artificially force the crops to grow.
More espresso.
More espresso, and to run heavier, more energy-intensive machinery to maintain this tight, rigid control over the land.
And producing that synthetic fertilizer is like incredibly carbon intensive. I remember reading in the brief about the Haber-Bosch process.
Right, the industrial method we use to pull nitrogen out of the air.
Yeah, to make the fertilizer.
Yeah.
It requires immense heat and pressure, which means it burns through just staggering amounts of natural gas.
It relies entirely on fossil fuels. So to force this short-term stability on the farm, the industry pumps millions of tons of greenhouse gases into the atmosphere.
Which accelerates the warming.
Right. And those gases accelerate global warming. That warming creates even more extreme weather. That extreme weather further stresses the farm, prompting the use of even more fertilizer. It is a self-accelerating, highly destructive loop.
So breaking that loop requires abandoning the espresso. We have to change the foundational layer of the whole system, which, according to the brief, is the actual dirt beneath our feet.
Yes, the soil.
This is where the research shifts its focus to organic farming and how it completely reimagines the role of soil.
Well, in conventional farming, dirt is essentially viewed as a sterile medium.
Like just stuff that holds the plant up.
Exactly. It is just an anchor to hold the roots while we artificially pump the plant full of chemical nutrients. But organic farming views the soil as a living, breathing ecosystem.
Okay, so how do they manage that ecosystem?
The primary goal of organic practices Things like rotating different crops year after year, applying massive amounts of compost, and utilizing cover crops is to increase something called soil organic matter.
Soil organic matter. I mean, it sounds like a pretty generic term, but the brief treats it like the absolute holy grail of climate resilience.
It really is. It's essentially composed of decaying plant and animal tissues, microbes, and carbon-based compounds.
So it's basically the biological engine of the farm.
Yes, and building it up requires a very deliberate strategy. Take cover cropping, for example.
Okay.
In a conventional system, after the main cash crop is harvested, the field is often just left bare for the winter, just exposed dirt.
Right.
But an organic farmer will plant a cover crop like clover or rye, not to harvest and sell, but simply to keep living roots in the ground.
And what do those roots do?
Well, first, they protect the soil from eroding away in the winter rain. But also, as those plants eventually break down, they feed the subterranean ecosystem.
Okay, wait, I have to stop you there and push back a bit.
Sure.
Because this contradicts almost everything we hear in popular climate discussions. We have always been told that planting trees, reforesting the planet, is the ultimate way to capture carbon.
Right, the classic tree planting initiative.
Yeah. Are these sources really saying that simply changing how we treat the dirt can turn a regular farm into a massive carbon sink?
It is a radical reframing, I know. But yes, the soil is actually one of the largest carbon reservoirs on the planet.
Really?
Yeah, it holds far more carbon than the atmosphere and all plant life combined. This is the process of soil carbon sequestration.
Okay, walk me through how that physically happens.
It starts with basic photosynthesis. Plants breathe in carbon dioxide from the air. We all learned that in school.
Right.
They use some of that carbon to grow leaves and stems, but they also pump a huge percentage of it down into their root systems.
So they're physically injecting atmospheric carbon into the ground.
They are, and they release it into the soil in the form of exudates.
Exudates.
Yeah, exudates are essentially liquid carbon. They're complex sugars that the plant sweats out through its roots.
Oh, wow.
And the plant doesn't do this by accident. It is
Okay.
actively feeding a vast microscopic network of fungi and bacteria living in the dirt.
It's like a subterranean barter system.
That is exactly what it is. The microbes consume those carbon sugars, and in exchange, they act as an extension of the plant's root system.
Oh, so they reach further out.
Exactly. They mine the surrounding soil for essential minerals and water and deliver them back to the plant. This is called nutrient cycling.
And that biological process essentially feeds the plant naturally.
Right, which completely eliminates the need for those fossil fuel-heavy synthetic fertilizers we talked about.
But wait, in a conventional farm, when a tractor comes through and aggressively tills the soil, like turning it all over and exposing it to the air, and then sprays it with harsh chemical inputs, what happens to that microscopic network?
It gets absolutely shredded.
Mix.
The physical structure of the fungi is destroyed, the microbes die off, and all that liquid carbon that was safely locked away in the soil suddenly oxidizes.
Meaning it turns back into carbon dioxide.
Yes, and it escapes right back into the atmosphere. Conventional farming turns the soil into a carbon emitter.
That is wild.
But by shifting to organic practices, minimizing tillage, and feeding the soil biology with compost and cover crops, the farm stops emitting and becomes a vital carbon vault.
Okay, so if the soil is acting like this massive living carbon vault, what happens to the plants growing out of it? They can't just be isolated crops, right? They have to interact with a much broader environment.
Right.
And that leads us directly into the above-ground mechanics of organic farming outlined in the sources, the role of biodiversity.
Exactly. Healthy, carbon-rich soil naturally fosters a vibrant life above the surface. Organic farms rely on complex habitats, supporting a really wide range of species.
We're talking pollinators, beneficial predatory insects, diverse bird populations.
And native plants growing along the margins of the fields, yeah.
So think about it like this. Growing a single crop across thousands of acres, a monoculture with synthetic chemicals, is kind of like putting your entire life savings into a single, highly volatile tech stock.
Oh, I like that analogy.
Right. If a specific disease hits, or a weird weather event targets that exact crop, the stock crashes and you lose everything. But organic biodiversity is more like a diversified mutual fund.
A biological mutual fund.
Yeah, it's an ecosystem insurance policy that absorbs stress.
That financial analogy translates perfectly to biological redundancy. When you have multiple different species occupying an ecosystem, the whole system becomes robust. It doesn't just shatter when challenged.
Okay, so how does that actually work mechanically? Say a massive swarm of aphids blows into a farm, ready to just decimate the cash crop.
Mm.
On a conventional farm, the response is to spray a broad-spectrum chemical pesticide.
Right.
How does the Organic Mutual Fund handle it?
It handles it through biological pest control, which is entirely reliant on the diverse habitat we just talked about.
So no spraying.
No. If an organic farmer plants a diverse cover crop, like, say, buckwheat, between the rows of their primary vegetables, that buckwheat produces nectar. That nectar acts as a natural beacon, attracting parasitic wasps and predatory beetles.
Like a mercenary army.
Basically, yeah, a standing army that lives on the farm year-round. So when the aphids arrive, the farmer doesn't need to scramble for a chemical spray because the ladybugs and wasps are already there.
And they just immediately begin feeding on the aphids.
Exactly. The biodiversity acts as an active immune system for the farm.
And I imagine that resilience extends to extreme weather, too. I mean, picture a heat wave hitting a conventional monoculture field. It's incredibly fragile. There are no natural defenses, no varying canopy heights to provide shade.
No complex root systems holding moisture deep down.
Right. The single volatile stalk just bakes in the sun. But the biodiverse organic farm has layers. Some plants might struggle in the heat, sure, but deeper-rooted varieties will thrive and provide ground cover. It adapts instead of breaking.
It uses life to support life. By refusing to artificially isolate a single crop from its environment, the organic farm actually leverages the natural defenses of the entire ecosystem.
So that biological redundancy, both the microbial life underground and the insect life above ground, that directly confronts the most immediate, visceral, physical threat of climate change that the brief highlights.
You're talking about the water equation.
The water equation.
Mm-hmm.
Water availability is the crisis of the coming decade. As the atmosphere warms, it holds more moisture, which fundamentally alters rainfall patterns globally.
We are losing the steady, predictable seasonal rains that agriculture depends on.
We are moving rapidly toward extremes. And this actually brings up a major mechanical question I had about the research.
Okay, let's hear it.
So, if climate change brings both prolonged, parching droughts and sudden, aggressive flash floods, literally opposite extremes, how can changing the soil act as a buffer against both at the same time?
It does seem counterintuitive.
It seems physically impossible. If you pack the dirt full of organic matter and compost, wouldn't it just become dense like a brick, making it harder for water to move?
Well, it actually does the exact opposite. And it all comes back to how soil organic matter changes the physical architecture of the ground.
Architecture, like how the dirt is built.
Exactly. Those decaying roots, the microbial networks, and the carbon sugars we talked about, they act as a biological glue. They bind the microscopic dirt particles together into clumps. Agronomists call them soil aggregates.
Okay, so the dirt becomes clumpy instead of powdery.
Yes, and that clumpy structure is highly porous. It is full of microscopic empty spaces, but the organic matter itself is highly retentive. It basically acts like a sponge.
A giant underground sponge.
Exactly.
Okay, so let's run the two extreme scenarios through that sponge. Scenario 1, a severe 2-month drought.
During a drought, those organic aggregates hold onto moisture deep underground, acting like microscopic reservoirs.
So the water doesn't just evaporate.
Right, and the complex root systems of the diverse crops can reach down into those pockets of humidity and tap into the reserves. The organic field stays green and viable long after a degraded conventional field has turned to dry dust.
Okay, that makes sense. But what about scenario 2? A catastrophic flash flood. Like a massive rainstorm dumps 4 inches of water in 2 hours.
Well, conventional degraded soil lacks those aggregates. It is often compacted by heavy machinery and totally depleted of life. So when that deluge hits, the soil acts like concrete.
Because it's just packed powder.
Exactly. The water cannot penetrate the surface. It just sheets right off, causing massive runoff.
Which washes away the topsoil.
It washes away precious topsoil, and it carries whatever synthetic fertilizers and pesticides were on the field directly into local rivers and streams.
So it literally creates a toxic flood.
Yeah. But the porous, aggregated structure of healthy organic soil allows that sudden wall of water to rapidly infiltrate.
Sponge soaks it up.
Right. The ground absorbs the floodwaters downward, slowing the momentum. It prevents the topsoil from washing away, and in the process, it actually filters the water and recharges the deep groundwater table.
That is incredible. So one physical mechanism building soil aggregates through organic matter solves 2 entirely opposing crises.
It really does. It improves water efficiency during droughts and reduces destructive runoff during floods.
It buffers the farm against the whiplash of a changing climate.
Exactly.
Okay, so we have mapped out the microscopic soil aggregates, the insect armies, and the atmospheric water dynamics. But we have to trace this entire massive supply chain back to where we started this conversation.
Right, to the listener's plate.
Yes, your plate. How do your daily choices at the grocery store connect to these sweeping agricultural shifts?
Well, the research brings the responsibility and the power directly to the consumer. Farm-level transformation is practically impossible without consumer-level support.
Meaning we have to buy this stuff.
Exactly. By choosing organic, whole, or minimally processed foods and supporting local agriculture, consumers are actively funding this transition. Not to mention reducing unnecessary food waste.
But I want to voice a very common skepticism here.
Because it is so easy to look at the multi-trillion-dollar global agricultural industry and feel completely insignificant. Buying a slightly more expensive organic apple or making sure you don't throw away that half-eaten bowl of spinach in your fridge, it feels like throwing a pebble into the ocean.
I get that.
Do the sources indicate that individual consumer choices actually restructure global farming?
The brief is highly realistic about this. It offers a crucial caveat, which is that there is no single silver bullet. Buying an organic apple does not single-handedly fix the atmosphere.
Right.
However, agricultural markets are incredibly sensitive to demand. Farmers operate on razor-thin profit margins. Transitioning a conventional farm to an organic system takes years of hard work
You have to rebuild the soil, sacrifice short-term yields.
and learn entirely new ecological management techniques. A farmer cannot take that immense financial risk without knowing there is a buyer waiting for the crop on the other side.
So the market demand actually dictates the physical landscape. Precisely. When you shift your purchasing power towards sustainable food, you are directly investing in that biological mutual fund. You are financing the farmer to plant the cover crops, to build the compost facilities, and to sequester the carbon.
So while one apple doesn't change the world, multiple sustainable strategies driven by compounding consumer demand over time that creates massive systemic shifts.
The economic engine of sustainable agriculture is built entirely by the people eating the food.
The journey through this research really reveals a profound shift in how we approach survival on a changing planet. Modern agriculture spent the last century trying to dominate nature.
Yeah, we tried to force yields with synthetic chemicals, heavy machinery, and rigid binary control.
But in an era of climate instability, that rigidity is breaking. Is the stressed-out system chugging coffee until it literally collapses?
And organic farming points to an entirely different strategy. It survives and even thrives not by forcing control, but by partnering with the inherent resilience of nature.
It mimics the messy, adaptable complexity of a natural ecosystem. And that invites a much larger, more provocative question for you to take away from this deep dive. If the systems that literally feed us and keep us alive only survive by abandoning rigid control in favor of natural adaptability, what if we applied that exact same ecosystem thinking to the rest of our world?
Oh, that's an interesting thought.
Right, like what if we designed our cities not as rigid concrete grids, but as porous sponges? What if we built our businesses not as vulnerable monocultures fixated on a single quarterly metric, but as resilient, diversified mutual funds?
Wow.
What if we stopped fighting the complexity of the world and started designing our lives to mirror it?
It is a blueprint for resilience that extends far beyond the farm.
It really is. Thank you for joining us on this deep dive. We hope it changes the way you look at your next meal. Keep exploring the systems around you, stay curious, and eat consciously. We will catch you on the next one.